Hello, folks. Greetings. So we are continuing our antiderivative exercises. Now, for the next set of exercise, I looked through those exercises, and then some of the things that's interesting in these exercises is that they are relying or they are expecting you to know a few things in the past. Sometimes it's algebra, sometimes it's um, basic arithmetic, right? And then one of the things that I thought that I got to provide you some clarity before we go and attempt these exercises is the idea of these exponents, right? So what I'm talking about is, and these exponent rules are something that it's better for you to learn right now. Just as a refresher, I think that you already know it, but as a refresher, it will be a good idea to learn that, right? So the first thing is that if you have something like x to the power of a multiplied by x to the power of b, then that is equivalent to x to the power of a plus b. Okay. As an example, I can tell you that if it is x to the power of 5 multiplied by x square, then you can easily say that is equal to x to the power of 5 plus 2, or that is equal to x to the power of 7. Okay. You remember this, you should remember this, but I'm just going to give you a refresher, that's all. So the same thing, x to the power of a divided by x to the power of b is equivalent to x to the power of a minus b. Okay, so that b becomes a minus b. Okay, so that is one thing that you got to remember. And let me get a new screen here. The other thing that is important is that, so if you have something like let me get my pen. So if you have something like a square root of x in arithmetic, I think if you remember, we used to denote that as x to the power of 1 by 2. Okay, and then the same thing, if you have a cube root of y, that is the same as y to the power of 1 by 3. Okay. So you got to remember that. So when you say that, hey, to the power of fractions, how does these fractions happen? That's because of any of the roots. If you're trying to find the root, that is equivalent to a fractional power. Okay, and that's how is that even possible? Is because, so think about it, right? Just as I want to create a light proof here is that, so that root of x multiplied by root of x is what? X, correct? And the same thing, you can put that as x to the power of half multiplied by x to the power of half, which is equal to x to the power of half plus half, based on what I showed you last time, right? And that's equal to x to the power of 1, which is actually x. You see that? That's why those fractions come into play. Now, one more thing that you got to know is that if you have x to the power of a, the whole to the power of b, that is equal to x to the power of a multiplied by b. Okay. So in other words, if you have x to the power of 5, the whole to the power of 2, that is equal to x to the power of not 5 plus 2, not 7, but 5 multiplied by 2, which is x to the power of 10. You see that? Okay, so remember that too. Now there are sometimes this weird combination where you will say that, hey, you are having a cube root of y to the power of 4. Okay, so how you can break this down is you can break this down into y to the power of 4, the whole thing to the power of 1 by 3. And that, you know, based on what we are doing here, it's equal to y to the power of 4 multiplied by 1 by 3, which is 4 by 3. Okay, so you can have these fractions like 4 by 3 to the power of 4 by 3. That's because you have something like this, right? And then I'm not having space here. Let me clear the board again. Let me clear it. So what I'm trying to say is that you also have, if you have something like a cube root of x, the whole to the power of 2. Okay. Again, that is equal to x to the power of 1 by 3, the whole to the power of 2. And again, you can use that formula as x to the power of 1 by 3 multiplied by 2, and that is equal to x to the power of 2 by 3. Okay. So again, these are all basic arithmetic, but you might have forgotten, so I'm just giving you some refresher because the next set of problems that we need to solve requires you to know this. Okay. Okay, now I think we'll solve some more problems before we come back to the drawing board. Because, you know, sometimes you do have, sometimes you do have to apply these concepts. Okay, let me see, let me go back to your book. Okay, I think yesterday we solved some of the problems until question 3. Now we'll go to the question 4. And you see that the very first problem is, hey, find me the find the antiderivative of, is right? Okay, so that's the question. So the question is, find the antiderivative of root of x, right? So if you want to find the antiderivative of root of x, what you do is something that that's why I just gave you these exercises, because then you can figure these concepts I explained, because then you can figure out what is going on, right? Okay, so now let's do the finding the antiderivative of, and I think it's easy for you to do it, but I'm just going to do it. I'm going to do maybe A, and let me do maybe D, because that D looks a little complex. It's not a big deal, but it's a little complex. And then maybe C, and maybe E, right? Let's do those problems. Okay, so let's start with the problem A. And let me go back to the board. So you're going to find the antiderivative of root of x. Now, based on what you learned so far, root of x is actually, so if dy by dx equals root of x, what is y? Correct? That is your question. Now, based on that, based on what we learned, we know that root of x is x to the power of half. And so y should be equal to, we apply the same formula for if dy by dx is x to the power of n, then y is actually x to the power of n plus 1 divided by n plus 1 plus c, right? So that is equal to 1 by 2 plus 1 divided by 1 by 2 plus 1 plus c. Now x to the power of half plus 1 is that, so you will actually do it like x to the power of 1 plus 2 divided by 2. Correct? Divided by same thing, 1 plus 2 divided by 2, which is 3 by 2. Plus c, right? And so that is equal to, I'm just going to put a draw line here. So that's going to be x to the power of 3 by 2 divided by 3 by 2 plus c. And then if you're dividing like that, things go upside down. So that's equal to x to the power of 2x to the power of 3 by 2 divided by 3 plus c should be the answer. And therefore I actually took a printout of all the answers of your book so that I can verify that even though I'm doing it, if what I'm doing doesn't have any mistakes, right? And so I'm just looking at the answer and making sure that the answer comes okay. Now, the only thing here, I hope I can rub this off a little bit. Is, let me rub some part of it because there's no space here. So the answer is right, but in your book they made it a little bit more sophisticated. So we did like 2. The answer came for us as 2x to the power of 3 by 2 divided by 3 plus c, correct? And I'm going to rub some of these parts too. Okay, so then what is that? That's actually 2. That's equal to 2, okay? Then you can say x to the power of half is basically root of x, and x to the power of 3 is x to the power of 3, right? So it's root of x to the power of 3. Remember that I showed you that when you do a root of x to the power of 3, that's equal to x to the power of half, or x to the power of 3, the whole to the power of half. And then since they are like that, then you multiply 3 into half, that will become 3 by 2, right? So they just simplified it even further and showed it in your book. Okay, so that is the final answer. Okay, so you got the idea. So it's just they are trying to test you on your knowledge of, instead of antiderivative in this case, it's about how do you break down your exponent, right? Do you have an understanding of how you break down these exponents? Okay, very good. Now I'm going to do clear the board, and then let's look at another problem. So the next problem I want to look at is x to the power of, I'm trying to make sure, x to the power of minus half plus 2x to the power of minus 2 by 3, right? Let me do that. Even before that, I'm not going to attempt b because you know that, right? X to the power of minus 3, then you do the x to the power of minus 3 plus 1 divided by minus 3 plus 1 plus c, right? That one is easy. Let's do the 1 by x to the power of 8 because that has some concepts that you got to remember. 1 by, let's see, what's the, is 1 by x to the power of 8, correct? Okay. Okay, so you do 1 by x to the power of 8, and then you know that is equal to x to the power of minus 8. Okay, I think even last class I showed this, because in theory, okay, how did I find that out? Is by 1 by x, you can say that it's x to the power of 0 divided by x to the power of 8, correct? And that's equal to x to the power of 0 minus 8. Therefore, it will be x to the power of, x to the power of minus 8. You see that? That's how that happens, okay? Okay, so again, it's very simple for us, because if we know the derivative is x to the power of minus 8, then the answer y equals x to the power of minus 8 plus 1 divided by minus 8 plus 1 plus c. And that is equal to x to the power of minus 7 divided by minus 7. And so I'm going to put 7, and then I'm going to put minus here, plus c. That should be the answer for the next one. Let me verify that. And we did x to the power of okay, so in your book, again, they've done something interesting, which is not a big deal. So you just put minus 1 by 7 x to the power of 7 plus c. Okay, because the x to the power of minus 7 will become 1 by x to the power of 7, and you already have a 7. So that's how the answer in your big book is given. So you got to go one step further and convert it back to the original way it was, like 1 by x to the power of 8, right? So 1 by x to the power of 8 becomes 1 by 7 x to the power of 7 plus c. Okay, good. Let's go to the next problem. The next problem I'll attempt is this one, x to the power of minus 1 by 2 plus 2x to the power of minus 2 by 3. Okay, a little bit more sophisticated. X to the power of minus 1 by 2. So I'm going to write the problem. Basically, f prime of x is x to the power of x to the power of minus 1 by 2 plus 2x to the power of minus 2 by 3. X to the power of minus 1 by 2 plus x to the power of minus 2 by 3. I want to make sure that I've plus 2x minus 2 by 3, right? Plus 2x minus 2 by 3. Okay. Plus 2x minus 2 by 3. Okay. So this is of the form that you have a function of x plus f of x plus g of x, that format, right? So for that what you do is you find the antiderivative of the first one, the antiderivative of the second one, and then add a constant to it, right? So in this case, this will be that is equal to x to the power of, so y equals x to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus 2 x to the power of minus 2 by 3 plus 1 divided by minus 2 by 3 plus 1 plus c, okay? And that's equal to, if we do that, it will be minus 1 plus 2 divided by 2. So minus 1 plus 2 is 1 by 2, right? So that is, properly speaking, that is root of x, correct? Because x to the power of 1 by 2. And then it will be again x to the power of minus 1 plus 2 by 2, that is minus 1 plus 2 is 1 by 2, and then root of x into 2, right? Because it will become 2 by 1, so that is 2. So 2 root of x plus, x to the power of minus 2 by, so I know that there's a 2, I'm going to put that 2. Minus 2 by 3 will become minus 2 plus 3 divided by 3, okay, as a common denominator. So minus 2 plus 3 is basically cube root of x, correct? X to the power of 1 by 3, because that 1 by 3 is the answer. So now this also will become the bottom, the denominator, minus 2, 3 plus 1 is minus 2 plus 3 divided by 3. Minus 2 plus 3 is plus 1 divided by 3. And then you make it upside down, it will be 3, right? So it's 2 multiplied by 3 plus c. Now you want to make those as special steps, you can do it. I'm just putting these steps because I know that I'm going to be limited in space. So now that is 2 root of x plus 6 cube root of x plus c. Okay, let me check the answer. Okay, so you see, whenever I do it this way, your book is doing it the other way. Okay, so anyway, I can put that. It's not a big deal. So they're saying 2 x to the power of 1 by 2 plus 6 x to the power of 1 by 3 plus c. Okay. So I converted that way, they converted it back. Okay. So anyway, it doesn't matter. It's the same thing. Okay. So you understand, if you know your exponents well, this is not a big problem at all. It becomes like basic algebra, right? But you got to know these basic exponent rules very well. Okay, how long it's been? It's been 23 minutes. Let me see if I can at least do one more. Let me go back to the problems. Okay, and when you find these, find antiderivative of, and then they give you these kind of problems, right? What I would suggest to you is just do the multiplication, right? In cases where if you can multiply, right? But if you can't multiply, then you got to go back to trying to do the f of x versus the f prime of x formula, okay? And so what I will do is I'll take the h, okay, which is the most complex it looks like of these, and I'll solve that for you. And I think if I solve that for you, you will solve the rest of it, is my understanding, but we'll see, right? So I'm just going to take this, the h question, or let me do this. Let me take one of the simpler ones, then let me go to the complex one, right? How about I take c and then I'll do the h, okay? Again, this is your question 5. How do you do it, right? So let's do 8x multiplied by 2x squared plus 3, the whole cube, right? So let me do that. 8x into 2x square. So it is, I want to find the antiderivative of 8x multiplied by 2x square plus 3 the whole cube. Okay. Plus 3 the whole cube. Okay. Now this one is, as you know, they are trying to test you on your chain rule, and so I'll put the chain rule down here. So the chain rule is that if dy by dx equals f prime of x multiplied by f of x the whole power n, I think, right? Then that is equal to f prime of x, no sorry, f of x the whole power of whole power of n plus 1 divided by n plus 1 plus c. Okay, so that's one formula. Okay, and then there was another formula that was given to you, and I'm going to do it and then I'll rub it off. Okay, the other formula that was given to you is if you have something like ax plus b the whole power n, then the antiderivative of that is ax plus b the whole power n plus 1 divided by a multiplied by n plus 1 plus c. Okay, so these are some of the things that you got to remember, but this one probably doesn't need that, but I just want you to these formulas to keep in mind, and as much as possible try to write them down. Okay, you can just put given the formulas so that you can remember these formulas just in case. Now in the American side, generally when you have a test, these formulas are given to you in the beginning of your paper. Okay, but I know that doesn't happen in many countries where they are expecting you to memorize, keep these formulas in memory. Okay, so that's why I just want to, the more and more you practice, the more and more you can remember. Okay, so let's start with this. This sounds like to me the formula about f prime of x and f of x the whole power n, right? So from this I know that I can find, so I know that f of x in this kind of situation, I know that f of x is 2x square plus 3. Okay, I know that. Okay, and if I know that, then I can find the f prime of x. Correct? F prime of x is, I need to just differentiate, and when I differentiate, this is 2 multiplied by 2 x to the power of 2 minus 1 plus that constant goes away because derivative of constant. So I'm trying to find the derivative of 2x squared plus 3. Okay, so the derivative of 2x squared plus 3 is 2 multiplied by x to the power, derivative of x to the power of n is nx to the power of n minus 1, right? So therefore I can do that. So that means f prime of x is actually equals 4x, because x squared minus 1 is that. So f prime of x is 4x, but the thing that is given to you is 8x. Okay, so that therefore I'm just going to draw a big line here. Let me undo it. I cut through that. Okay, let me do a straight line there. Okay, good. Okay, so what I can do is I can say, oh, that's equal to 2, okay, into 4 of x is f prime of x, right? 4 of x is f prime of x, correct? And that multiplied by 2x squared plus 3 the whole cube. Okay, so therefore I can ignore this. I still need to keep the 2, so it is 2 multiplied by 2 to the power of 2x squared plus 3 to the power of n plus 1, that is 4, divided by 4 plus c. And of course this 2 and this becomes 2, so that is 2x squared plus 3 power of 4 divided by 2 plus c. Okay, and I'm going to verify your answer for that is the question 5. Let me check. I'm just going to go back and check the book. It is the 5th problem and the answer for C. Okay. So the answer for C is, the book says it is 2x squared plus 3 to the power of 4 divided by 2 plus c. Okay, so that is correct. So it doesn't matter how big you are, sometimes these calculation mistakes actually happen. So it's better to check the answer, especially when the answer is given, right? And the answer is right. Okay, so that's to summarize how I solve this problem is, when you have something, some expression multiplied by some other expression to the power of it, you got to kind of see that, can I break it down into the form f prime of x multiplied by f of x the whole to the power of something. So given that I know that, if that is the case, then I know what is f of x, which is just whatever the expression is there inside this power of situation expression, right? A power of operation. So you take that, you actually differentiate it, and when I actually differentiated that, I got a 4x. So if I can somehow break that down into a constant plus whatever the derivative is, then I can keep that constant and then go and apply the chain rule formula that was given to us, and then you get the answer. Okay, not a big deal, but it's just little involved, so make sure. And then the other thing is, make sure that your steps are right, make sure you write your numbers right, make sure you put your steps right, because sometimes those mistakes can happen, right? And then do it in a very calm and step by step fashion, and you can get it. Okay, now I'm going to take the more complex one. It is 3x squared plus 4x minus 7. 3x squared minus 4x plus 7. 3x squared plus 4x minus 7 into x cubed plus 2x squared minus 7x. That into x cubed plus 2x squared plus 2x squared plus minus 7x Yeah, I made the mistake in both the cases. So that is a minus 7, and minus 7x. Oh, man. Minus 7x. Okay, if that is the given f prime of x, or if that is the derivative a, find out what is the antiderivative, right? So again, here actually the problem looks complex, but is actually much more simpler than what you think, right? And the other one, the power of, is what? I want to make sure that it's the power of 10. Okay, power of 10. Okay, that's power of 10. Okay. So again, you can apply the chain rule, and actually, if you look at it, if you actually do it, it's actually very, very easy, right? So we just need to see if it is of the form x f prime of x multiplied by f of x to the power of 10, right? And so therefore we know f of x is equal to x cubed plus 2x square minus 7x. Okay. Now, if you find the derivative of that, what is that? Okay, 3x square, right? Derivative of x to the power of n is derivative of n x to the power of n minus 1, right? So it's 3x square. And then let me make sure. Yeah, I want to make sure that I'm doing this right. That was a plus. Okay, and then plus 2 multiplied by derivative of x square is 2 multiplied by 2 x to the power of 2 minus 1, which is x to the power of 1, that is x. Okay, minus 7, and here it says x to the power of 1, well, that is actually equal to 1 x to the power of 1 minus 1, which is x to the power of 0, and x to the power of 0 is 1, and therefore that is minus 7. Okay, so basically what you established is that your f prime is actually 3x squared plus 4x minus 7, which if you see is the same as that. So this is of the form f prime of x into f of x to the power of 10. Okay, so then your antiderivative is simple. It becomes x cubed, and taking the second expression, 2x squared minus 7x to the power of n plus 1, which is 11, divided by n plus 1, which is 11. Okay. So you see that even though it looked like, oh man, what is this two expressions, big equation, how to find the derivative? It's actually very simple once you break it down. And the book answer is x, let's see, I'm going to go back to my question. It is 5h. Okay, so 5h is x cubed plus 2x squared minus 7x to the power of 11. Again, the one thing that I am getting lost in all of this is I always need to put the plus c. I forget that, right? We always need to put the plus c divided by 11. Okay, and the book also, the answer says that's the answer, so I am right. Okay, so that's good. 39 minutes. Okay, let me see. Well, let me attempt the sixth problem. Okay, one more problem. I know that it's little tiring, but it's not little tiring, right? It's just fun, right? So I know that the video is got a little longer, but I would like to address at least one more problem before I say that, okay, this is it for today, and then I can continue tomorrow. So the other problem you see is it says that if dy by dx equals x cubed minus 3x squared plus 5 and y is equal to 4 when x is equal to 1, find an equation of y in terms of x. Okay, I'll break this down. It's very, very simple. If dy by dx equals x cubed minus 3x squared plus 5. Okay, so I'm just going to write that down, write the problem down. If let me get a new board. Okay. If dy by dx equals, they're given an equation which is x cubed minus 3x squared plus 5. X cubed minus 3x squared plus 5. My memory is not that good today, so I just want to verify x cubed minus 3x squared plus 5. X cubed minus 3x squared plus 5. Okay. Then they're giving us interesting thing. They're saying y is equal to 4 when x equals 1. So the value of y is equal to 4 when x is equal to 1. And they're saying when x is equals to 1. Find an equation of y in terms of x. Okay. So then they're saying find out y. Okay, in terms of x. So this is, I mean, they will give you this kind of problem. They may also tell you that, hey, you know what, a curve equation, the derivative of the slope of this, or the trend, or the trend line of this function is x cubed minus 3x squared plus 5. They pass through 4 and 1. Now find the equation of y in terms of x. You might get questions like these also. Okay, what do you do? What you do is that, so they've given you the derivative. The first step is you go and find the antiderivative of that derivative. Then once you found the antiderivative of the derivative, then you substitute y for 4 and x for 1 and find out what is c. Once you find out what is c, all you got to do is then rearrange the equation to say y equals whatever that is. Okay, I'll show it to you step by step, don't worry, but I just want to give you an overview of how you solve the problem. So the first thing is, if this is the case, then first thing we need to find out is y. Okay, what is y? Y, as you see, is multiple terms, and you got to find the antiderivative of each term, right? So when you have x cubed, that is actually x to the power of 3 plus 1, which is 4 divided by 4. Okay, the antiderivative of the first term, minus 3 into antiderivative of x squared is x cubed divided by 3. And then antiderivative of 5 is 5, and then think of it as x to the power of 0, that will become x to the power of 1 divided by 1, okay, plus c. So you found the antiderivative, and by the way, this 3 and 3 will go away. I want to eliminate things that is already gone. Now what we do is that we say that, oh, okay, so now I need to substitute y and x. So what does it say? It says 4, y is 4, when x is 1. So 4 equals 1 to the power of 4 is 4. So 1 by 4 minus x cube is, again, 1 cube is 1, plus 5 multiplied by 1 is 5, plus c. Okay, so that one is equal to 1 by 4 minus 1 plus 5 is 6 plus c. Okay. Now if you make 4 as the common denominator, then you can make that as 1 minus 6 times 4, right? So that's 24 divided by 4 plus c. Okay. So I'm going to rub some of these steps off just to create some space. So based on our last step, okay, 1 minus 24 is 20 minus 23. So so 4 equals minus 23 divided by 4 plus c. Okay. Now if we take c this side and bring the 4 that side, then that will be c is equal to 4 plus 23 divided by 4, right? I'm going to rub this off. And again, we need to take 4 as the common denominator because we pushed the minus 23 by 4, becomes plus 23 by 4, but 4 plus 23 by 4 is actually 16. 4 into 4, 16 plus 23 divided by 4. Okay, so c is actually equals so that is 9 and 3, okay, 39 by 4. So you got an equation where you found out the value of c. The value of c is always 39 plus 4, okay. So once you know what is c, which is, so the c is equal to 39 by 4. Now all you got to do is, I'm just going to rub all these things off. So all this exercise you did is to find the value of c, okay. And now we found the value of c, which is 39 by 4, okay. So it's saying that, hey, tell me what is y in terms of x. Y is equals the same equation, right? I'm just going to rub these off. So it's x to the power of 4 divided by 4 minus x to the power of 3 plus 6 plus 5x plus 39 by 4, and that should be the answer. Now I want to check in the book if the answer is right. X to the power of 4 by 4, x to the power of 3 plus 5x minus 1 by 4 is what they're saying. So I made a calculation problem. I made a calculation mistake, I'm guessing. So let me go back and revise that. So the 39.4 is not right. It's actually 1 by 4 is what the book says. So I'm going to solve this problem again. The equation seems right. So let me solve the problem. Actually, you might have found what the calculation mistake is, but I just want to try it again. So it says y is equal to the 4 equals x to the power of 4 divided by 4 minus x cubed plus 5x plus c. So that is equal to x to the power of 4, x is 1, so that is 1 by 4 minus 1 plus 5 plus c, right? That is equal to 1. So maybe that is the issue. So 1, that is equal to 1. So you have the minus 1 plus 5, correct? It's minus 1 plus 5. Because the 3x square and the, okay, so it's minus 1 plus 5. That is, so 1 by 4. It will become a plus, minus 1 plus 5 is 4, plus c, and so yeah, I should have simplified this. So c is equal to 4 minus 1 by 4 minus 4, correct? So 4 and 4 cancels out. So c is minus 1 by 4. That was my calculation mistake. Okay, so therefore, so the way I calculated the x cubed plus 5x, substituting x, was wrong. So it is minus 1 by 4. So c is minus 1 by 4, okay? So I'm going to take that c off, and I'm going to say that is minus 1 by 4. Minus 1 by 4, okay? But you know what the procedure is and how to do it. And again, this is a lesson for you that anybody, big or small, and by the way, I'm not rehearsing anything here, right? I'm just directly putting this because after work I come and do this for you. So I don't have anything to rehearse and make it correct. So I had the wrong answer, so I went and corrected it. And by the way, if I'm teaching this to you, you can see that a small mistake here and there, if you're not careful, you will find the mistake. But that's the procedure, right? You find the y, then find the c for x and y value, and then substitute it, find c, and then get the answer. And I need to take this 4 off, and I say that, okay, y is equal to that, okay? Going back, so it's let's look at the 7th problem. The 7th problem is if f prime of x is 4x minus 7 and f of 2 equals 5, find an equation for y equals f of x, right? So it's exactly the same problem like 6. Only thing is they put f of 2, right? F of, so that means x is 2 and y is 5. So the above question, y is 4, x is 1. So in this question, x is 2, y is 4, y is 5, right? Do the same thing that what I showed you, okay? 8th question, exactly the same thing, right? But 8th question, there's a little twist. They are saying that, hey, x is minus 3, y is 4. Find c, form the equation. Once you form the equation, find f of 1. So substitute that by 1, okay? So you can attempt 7 and 8, okay? And what I will say is comment on it. If you, once you attempted it, if you have problems there, you have questions there, I'll attempt it, okay? It's not a big deal. Let's go to the 9th question. The 9th question says, given the gradient of the tangent to a curve is given by dy by dx equals 2 minus 6x. Remember, gradient of a tangent means what? That's a derivative. So all they're saying is, hey, the derivative of y is dy by dx equals 2 minus 6x. The curve passes through minus 2 and 3. That means x is minus 2, y is 3. Find the equation of the curve. So basically it's the exact same problem like the one I solved right now, except for the fact you now need to say y is 3 x is minus 2, find c, and then find the equation. Okay? I don't have to solve that for you. You can solve it. Same thing, dx by dt equals t minus 3 the whole square, right? Dx by dt. Okay? T minus 3 the whole square, and x equals 7 when t equals 0. Find x when t equals 4. Okay? See, so far we tried to find dx and dt, so that means when x is equal 7 when t equals 0, right? They just turned slightly, that you hopefully that you don't get confused by dx by dy, right? Here y became, sorry, dy by dx, right? So y became x here, okay, and x became t here. Got it? Okay, so that means y is 7, x is 0. Okay, now you need to find what you need to find, and after you find it, you substitute that for t equals 4, what to do, right? Seems like a very interesting problem. Maybe I'll solve it. The next one is they are doing a d square y divided by dx square equals 8, and dy by dx equals 0, and y is equal to 3 when x equals 1. Find the equation of y in terms of x. Okay. Very interesting problem. So the 11th problem and the 12th problem, I will do it tomorrow, but you know what? Figure it out how to do it. It should be easy if you study derivatives. And what is d square y divided by dx square? What does that mean? Then what does it mean dy by dx equals 0, or some of the things that you need to go back in your book itself, you can go back and see. But I'll try to solve that tomorrow, okay? And few other things I'll try to solve tomorrow. But go ahead, look at the video, try to solve some more problems, come back to me with questions, then I'll continue to solve the problem. So there's probably 1 or 2 more videos I need to make, because there's 21 problems here, and then we are done with the basics of antiderivatives. Okay, of course today's class is 1 hour, so sorry for that. Hopefully in future I'll try to make this a little bit more simpler. Okay, bye.